of the messages that we've got from the speakers this morning. And of course the first one, which is one that we're hearing more and more about, is the fact that the Earth's climate system and the chemistry of its oceans are changing, and I think we've seen further evidence of that as it pertains to coral reefs. And of course, coral reefs have actually had the dubious honour of being really the first ecosystem to really show that climate change not only changes things gradually, but you get a number of tipping points. And of course, bleaching's one of those, where everything's okay 1 week and then a week later you've got something that looks like this. And of course, coral reefs are also useful in that they demonstrate the connectivity of our natural systems to people. Now, we should have woken up to that just through, the study of the way we interact with the universe. But in the case of coral reefs, it's a very stark connection, where you have, for example, such as in Southeast Asia, over 100 million people that live in coastal areas and look to the sea for their food and income and resources. And that connectivity is so strong that it's quite easy to argue that if you start to lose these things, you will start to impact the lives of those people in very dramatic ways. Now, of course, on the Great Barrier Reef, we're not immune as well. And of course, we've said already that we've got this huge tourist industry. The second largest industry in Queensland is one associated with the reef. And of course, something like this won't get Americans and Europeans onto planes to fly all the way over to see something like this. So there is also some sort of connection between the fate of the sort of industries that we depend on here in Queensland and the state of the reef. Well, I wanted to extend what we've seen here today by asking 3 really simple questions. Well, they're not really simple, but I'll say they're simple. The first one is to ask the question, what's a safe climate? Because actually that's really what we've got to ask with respect to the global climate change issue. We've had projections in the future. We've got this excellent body of science built on scenario planning, that's built into scenario planning as part of the Intergovernmental Panel on Climate Change. But unless we're sure that what we really care about in this particular group or elsewhere is going to be safe, then we're going to be fighting a losing battle. So I'm going to ask that question. Is it 550? Is it 800? What is it? The second one is, what's the consequences of an unsafe climate? And this will relate to a study that some members of the Centre for Excellence and some other people have done to try and relate the changes you see in the state of coastal ecosystems in Southeast Asia and what the consequences might be for people. And then the last thing is, I want to sort of have a look at how we're going as we go towards Copenhagen in terms of, this is what the future looks like, and that's what we know is safe. And hopefully the two will come together. Well, safe, of course, means to be free from harm or risk. And that's pretty straightforward. So if you said that for a reef, it would be coral reefs that are free from harm, damage or risk are those that they're in a safe climate. Now, we already know that over the past 20 years we've been seeing evidence that corals and the reefs they build are not safe. And in fact, these are just some, the backdrop is 2002 on the southern Great Barrier Reef, where there was a loss of about 30 to 40% of the living corals around the Keppel Islands. That, of course, was repeated in other inshore environments. We were relatively lucky compared to some of the events that have occurred during those very warm periods like 1998. And there's a study here which I know some people have some viewpoints on. This is a study done by Bruno and Liz Selleck, which really was looking at 6,000 studies and just asking the simple question, what was the average coral cover in places in Southeast Asia, Australia and the Western Pacific in 1980 versus today. And the surprising conclusion, perhaps not surprising to some, was that the average coral cover has shifted almost in fact in every area of this region to about 30 to 40% less than it was in 1980. So there's evidence, I think, of an unsafe climate. Cobbled to that, of course, we saw Malcolm talk before tea about the Glenn Diath and co-authors study showing a 15% drop in calcification since the 1990s. And that study has also been matched by a study in Thailand that shows almost a similar thing. And I'm aware of another manuscript that's coming through the system at the moment, which shows that acroporas have done a similar thing in various parts of the world. So you'd have to say we don't have things in a safe context right now. Well, what's the definition? So if we know the definition of safe climate, then we might say, well, actually, now let's go back to the CO2 record and ask when bleaching first occurred, what the CO2 level was, because that's really the trigger point above which you start to get into territory where you've got regular bleaching events. And if you believe the Bruno and Selig data, we're in this slippery slide downwards. No matter how well you manage your reef from local factors, there's this 1 to 2% decline per year. And this is something that I put together last night. It shows the CO2 record from Hawaii. And if you look at 1979, when we had our first bleaching event, we have a CO2 concentration of 336 parts per million. Of course, you have to look a little bit further back because that's a lag time. The temperatures take some time to appear. So if you were to be optimistic, you'd go back 10 years to look at what the CO2 concentration was then, which would then determine the temperatures 10 years later. And you do that and you get to this level of 324 parts per million, which of course for many of us is extremely challenging because that's a very low number that we've exceeded at our current 392 parts per million. All right, so put that out there. That's what we do as scientists, isn't it? We just sort of flop it on the table and let the policymakers deal with it. Where's John? Well, of course, this number, as we've seen earlier today, and I'm sure you're aware of, is a number which is down near where we've been over the past 740,000 years, possibly millions of years in terms of CO2 levels. And this is the Vostok ice core, again, going back in this case to 420,000 years. And we see the CO2 concentration wobbling up and down, as has been pointed out, because of the Milankovitch forcing effect. And of course, when you look at the top value here, it's well below where we are today, and of course, anything that we're projecting into the future. So if you then ask, there are many factors that affect the health of coral reefs. If you try and put these things together to get some perspective, and we did this in a science review in 2007, we calculated the carbonate ion concentration based on CO2, an assumption about total alkalinity and sea temperature, and we're able to then plot what the carbonate ion concentration was in a typical tropical sea, and we had the matching sea temperatures here. And the message here was that over even the most dramatic shifts of the past between ice age and warm period, we've remained in a tight bubble of points over time. And of course, when you look at where we are today in that scheme, we're well outside that cloud of points, and we're well aware that we're approaching two critical thresholds or tipping points. One of those, of course, is that if we increase sea temperatures by 1 to 2 degrees more, we're likely to see, at this point, the best evidence points to it, catastrophic bleaching within 30 to 40 years as we approach those temperatures. The other one is that, and Malcolm addressed this to some extent, that if you look at the concentration of carbonate ions that's required to have coral reefs, omega, where is he? Omega. If you look at that number, sorry, I won't say any more. You won't talk to me either. You start to come close to that threshold. So we're essentially approaching two things we know are going to cause trouble with coral reefs. And so this idea that a safe climate might be around 325 is not ludicrous when you look at where we've come from and as we approach those thresholds. So in March this year, I went to the Copenhagen summit with 1,600 other climate experts, and there was a very interesting discussion right at the end. And as I think Janice said, the messages from this conference are quite unsettling. Because it's just saying that we're on the worst case scenario, above the worst case scenario, it's happening faster than we thought, and we have minimal time to respond. But one of the messages came right at the end where Fogh Rasmussen, this chap here, by the way, there's been 3 generations of Danish prime ministers called Rasmussen, one after the other. And I was wondering whether I wasn't getting their names right, but apparently that's what you have to be a Danish prime minister. Now, this guy at one point said, look, we're hosting the climate negotiations at the end of this year. What's the message? The message as I see it, you want me to get everyone to negotiate towards a 450 parts per million 2-degree target. And there was a hush in the audience, and immediately Will Stephan and some others said, oh, no, 450 is a dangerous place to go. We have to be well below that. And so there's been this miscommunication, if you like, between the scientists and the policymakers, and I think this is a very important issue. We need to be very careful about how we're messaging the science, because we've been talking about 450 and these things happen, and they've gone, oh, okay, that's good, let's aim for that. But that's actually where we get into really serious issues, not only with coral reefs, it's rainforests, it's ice sheet breakdown. You put 2 degrees above Greenland, you start to really accelerate that melting. So it's not the place that we should go. And at the moment, everyone's negotiating for that right now, apart from one country in the Caribbean, which is probably an island. Okay, so what are the consequences of exceeding this number? Well, if we just go to some of those scenarios, the 450 number, and ask the question in areas where we can demonstrate real connectivity between coastal ecosystems and so on, we can probably get a picture of this. Now, the Coral Triangle represented a very a good opportunity in this respect. And we've heard a little bit about this. We're going to hear more about this tomorrow with John Tanzer talking about, and some others, about the importance of this region in terms of biodiversity and Australia's involvement in trying to get some action on the ground in terms of solving the problems that come up with not only climate but with too many people. And just to remind you, this area. Oh, and this is the report. It was a cast of thousands, had lots of centre people in it, but it also had people like Ali Green and Rick Leck and others who really put their heart and soul in this thing so we could launch this at the World Oceans Conference in Manado. Anyway, the bottom line is that it's an amazing place. It's the centre of biodiversity for almost everything. I'm sure it's the centre of biodiversity for cockroaches, but you've got mangroves, seagrasses, coral reefs, and so on. And it's also an incredibly important area in terms of human population. Oops. Now, Janet Luff, I'm going to get really nervous. Janet Luff headed the climate sort of section of the report, and what was found here was, I think, quite interesting, because there has been a bit of an attitude that this region might have some stability with respect to the climate, these cap ideas and the Pacific warm pool and how it behaves. But when you look at the numbers, there's been almost similar sorts of changes to many other parts of the world. So in this case, there didn't seem to be a lot of evidence, or it's still being debated as far as these changes. When you then looked at a regional aspect, there were some really interesting things that came up about how fast things are changing. And this is a piece of work put together by Eileen Penaflor, where you've got essentially different rates of change per decade. And so here you've got 0.4 degrees Celsius per decade, which of course means 4 degrees by the end of this century, and that's over a large part of this very important region. But interestingly, there are parts where you've got a downward trend in temperature. And there was a question, I think, from someone in the audience about, were there regions where you could perhaps shield biology from climate change? And it would seem that there were some of these regions that might have an opportunity. We've seen this figure before. I'm only showing it because there is also this interesting observation that as you increase CO2 in the atmosphere, the blue water is, by the way, what you need to have for a coral reef. As you get up to about 500, the sort of carbonate-rich waters, the remnants of those are clustered in this region. Now, whether that plays into some sort of advantage is quite interesting. Now, if you go to the higher scenarios, there's no question that we're going to see more bleaching, less calcification, and of course the prospect sooner or later where we start to lose the reef structure and of course the services, the fish populations, and eventually affecting the human beings. And of course at the same time, and this is something I learned from this, was that you can't really tease out coral reefs from the other ecosystems that are lining the shore there. So Kath Lovelock's, I think, in the audience, so I'm being good. Where are you? No, she was at dinner last night, so I got fearful and thought I should put in a mangrove slide. You tell her, John, all right? Anyway, the problem here when you talk to these people is rapid sea level rise, and the problem where you've got communities built right up to the seashore line, and so you've got no place for these ecosystems to go. And of course, these are the nurseries for fisheries and so on. So one of the projections that was done was to look at what would happen if you flooded, you had a 1 metre sea level rise. And as has already been said, people like this guy here, Stefan Ramstorff from Potsdam, they're now, they think that the assessment report from the fourth assessment of the IPCC is horribly underestimating the rate of sea level change. And at this conference they're saying, look, the minimum under all scenarios is 1 metre, but it's more likely to be 2 to 3 metres by the end of the century. Now if you do this, it's sort of deceptive. You look at the Coral Triangle and you put the sea level rise in there, and you think, well, it's these little red bits, you know. Well, actually, that's where all the people are living. And it's really interesting when you zoom in there and you appreciate how much of these coastal areas are going to be affected by sea level creep. You've also got to realise that it's not just the infrastructure, it's also water supplies because of the salinisation of coastal aquifers and so on. So when you do this and you realise that there's 100 million people living in this coastal area, you suddenly see that it's actually not hard to argue that we might be unsettling and having 50 million people on the move. And of course, Australia and New Zealand would be the places where those people might want to go after trying, you know, mega cities like Jakarta. So this becomes more than just simply an issue of coral reefs and coastal ecosystem. It becomes food security and eventually regional security. And I think this is really the way we've got to translate it if we talk about getting action on climate change. We've got to go beyond our communities and say, look, it's very sad. I might have dreamed about coral reefs as a boy, but they're gone now. No, this is really going to have implications within 30 to 40 years that it will have, you know, potentially explosive issues for Australia. And of course, this climate change chain reaction, this is very much going to be something that's going to be debated, I think, and pushed in Copenhagen, that this is really a chain reaction we need to pay attention to. So what actions must we take? There's been a number of really interesting papers that have come out in the literature. If you were to imagine the targets for 2 degrees, there's a very sort of world expert group at the Climate Institute at Potsdam University who have actually gone in and tried to take all possibilities and give the probabilities of what happens when you have certain emission scenarios. And the paper to read is one called Halfway to Copenhagen, No Way to 2 degrees. So here they're saying, if we take what countries are now committed to and we ask, are they going to keep global temperatures below 2 degrees and CO2 levels no higher than 450, you find that the red curve is what we have right now. That's Annex 1 and Annex 2 countries. It's developing and developing countries, the commitments so far. And you can see that we're roaring away up to, this band of CO2 levels, which is way higher than we think is safe. I mean, I'm being ultra-conservative here, saying that safe might be 450. Well, I think the argument I've made is that it's 320. That's actually where we've got to go. This is what you'd have to do with emissions. This is the halfway to Copenhagen trajectory. This is the trajectory which would get you the blue, which would keep you below 2 degrees. This is 1 trillion tonnes left of carbon to put back into the atmosphere. Between 2002 and 2007, we burn 234 trillion tonnes of carbon. So we've got to cut back rather steeply, I would say. But at the end of the day, this still puts us up to that 2-degree level. And I think by what we've learned over the last couple of decades, that number isn't safe. If we see 1998 continue to occur, even if it occurred every 10 years, I don't think we'd have much left in the way of coral cover. And of course, we have all these other issues and so on. So Jim Hansen at NASA, who has been promoting this idea that we need to actually go back in terms of our CO2 levels, produced this assessment of what we'd have to do in terms of our burning of oil and gas reserves. And there are two models there. They resemble each other. But you can see that really within the next decade, we have to be in free fall as far as our use of fossil fuels, unless something like sequestration, which isn't working on a wide scale, begins to work. And so this is another paper which I think is of interest to read. Jim, of course, was one of the people that George Bush silenced, or tried to silence, during the Bush presidency. Well, a lot of this actually depends on how committed we are. And in fact, it's really interesting to look at the business as usual scenario and to hear this point of view that we have at the moment, which is that, it's going to be too expensive and it's too, we can't afford to do it. That's just complete bollocks. And in fact, one of the demonstrations about what we could pour into something if we really did care about it is what happened during World War II. And in this case, you've got your different countries here, you've got Pearl Harbor, and then you've got the percent of the national income that's spent on fighting a war, or prosecuting a war in the case of Germany and Japan. And of course you can see that we can ramp up quite quickly to solve the problem. Now what does it actually cost to do? It's actually less than 2% of GDP growth to get below 450 parts per million. This is, Nicholas Stern, it's a whole series of fairly high-powered economic modelers and experts that are telling us that, we can get there. And so I suppose I'll just leave with the idea that that's what we have to do on the mitigation side. I don't think we have any options. We have to bring CO2 down, back down to those warm period concentrations. And at the same time, and this is what we're going to hear about from researchers this afternoon and tomorrow, is we've got to ramp up the dealing with the other issues and the consequences of climate change, because getting back down to that 320 part per million level will take time. But of course we know from work that was done by members of the centre led by our fearless leader, Terry Hughes, that actually if you, for example, overfish a reef, in this case cage a reef and get rid of the fish, you can turn a reef from a nice coral-dominated system into a seaweed-dominated system after a bleaching event. And so this really works. This recovered 3 times faster than those that didn't have fish. There is good evidence that dealing with those other stresses on coral reefs will buy important time while we try to get the mitigation issue under control. All right, so I think in summary, I would argue that a safe climate is well below 450, and we have to get there. The consequences are serious, not only in Australia but in our regional neighbourhood. And of course the actions we have to take, it's self-evident if you look at the Hansen and also the Minehausen modelling. It's getting to emission levels that are well below 10%, 90% reduction in emissions over the next couple of decades. And a big challenge, but it's actually possible. Thank you very much.